Assalamu alaikum wa rahmatullahi wa barakatuh. How are you? I hope you are doing fine. Today is another day in the 7th week of our third term, and the topic we are going to discuss today still remains the same as the topic we have started since 2 weeks ago, that is the gear system. But we are going to take another subtopic under that gear system topic today. About 2 weeks ago, we started gear system. We discussed its meaning, its working principle, its types of gears, types of gear system, functions of gear system. As the term is running to an end, our scheme of work is also being gradually exhausted. So the last topic that we are going to discuss for this term is the gear system. So it is just the subtopics under that major topic, gear system, that we are going to be discussing for about 4 weeks, because it's an extensive topic. So if you have not forgotten, as I've said, we have started this topic since 2 weeks ago, and we are still on the topic today. Even next week is going to be based on that topic too, because we are going to treat worked examples on gear system. So today, what we are going to discuss on gear system are the applications of gears and gear ratio. The applications of gears and gear ratio. That is what we are going to discuss today under the major topic, the gear system. Gear system is applied in the following examples, like cranes, clocks, automobile drives, and electronic recording machines such as video and CD players. So those are a few applications of gear system. Now let's go to the gear ratio. For gear ratio, we have about 2 definitions for gear ratio. The first definition here is that gear ratio is the ratio of the number of teeth in the driven gear to the number of teeth in the driver gear. So gear ratio, as defined in this first expression, so is the ratio of the number of teeth in the driven gear to the number of teeth in the driver gear. And when we look at the equation written below the definition, so we can see it that gear ratio is represented by GR. So and it's written in a simple equation: number of teeth in driven gear over number of teeth in driver gear. We all know what they call the driven gear. So the driven gear is the gear that is attached to the load side of a machine, and it's also the output gear. So that is the number of teeth it contains. So when we count it, so we put it as our numerator, and we put the number of teeth, the driver gear. The driver gear is the effort gear. You can call it effort gear, you can call it input gear. So that is the driver gear. So the driver gear is the one that is being driven by the prime mover of the machine. So and you count the number of teeth that one also contains. So you put that one as denominator. So as you can see it in the equation written. So that is how to calculate the gear ratio. And when we look at this diagram, so it's a typical example of a gear system. So we can see the first gear. The first cog contains 25 teeth, and that is the driver gear. So because it is the first gear is always the driver gear, that is the input gear. That is also what they call the effort gear, because it is, if you don't want to use machine to drive that one, you must use your hand. You must drive it manually. So when you drive it manually, you are applying your effort. So but the driven gear is the one that is attached to the load side of the machine. So you can see it, that is the gear B is the driven gear. So it's having about 75 teeth. So and according to the equation of the gear ratio that we have discussed, so if you want to find the gear ratio of this gear system, so you put the number of teeth of the driven gear, you put it as your numerator, which is 75. So the number of teeth of the driver gear, you put it as denominator, which is 25, and you find it. So when we find it, so the answer got is 3. That means the gear ratio of this gear system is 3. So that is what they call gear ratio. But at times, because there are about 2 definitions of gear ratio, at times you may not be given the number of teeth of the 2 gears. So you may be given the speed of the 2 gears. So in this second definition, the gear ratio is defined as the ratio of the speed of the driver gear to the speed of the driven gear. So that means if you want to find gear ratio using this formula or using this definition, so you are going to place the driver gear speed as your numerator, while the driven gear speed will be your denominator. So that is what you are going to use to find that one. And if you look at the formula, you can see GR is equal to speed of driver gear, which is represented by S subscript capital D, over speed of driven gear, which is represented by S subscript small d. So that is what they call gear ratio also. So if you are given the speed, so if you are given the speeds of the 2 gears that make up a gear system, so that is how you are going to find the gear ratio. So and the answer is going to be the same thing with the one you got with the number of teeth of the 2 gears. So that is how they find the gear ratio. So and if you want to compare this one with the one in which you are given the number of teeth, so we can see that the small one, which is the driver gear, so because of its smaller size, so it's going to have higher speed. So the speed is going to be 3 times that of the driven gear. So that means you place 3 as your numerator, which is the amount of speed of that small one, and you place 1 as denominator for the driven gear speed, which is the speed of the driven gear. So and the answer is going to be the same thing, so as what you have got in the gear ratio, in which you use the number of teeth of the 2 gears. So those are the 2 definitions of gear ratio, and inshallah, so we are going to do more examples on gear ratio in our next lesson. So these are the 2 questions given to you on the lesson for today. So the first question, you are asked to state the two definitions of gear ratio. The second one, you are asked to mention any other 4 applications of gear system apart from those stated in this note. So those are the 2 questions for you as an assignment. So may Allah make it better understood than how it has been delivered. Thanks so much.